Welcome to FETN. I'm Jeff Tokar, coming to you from the beautiful Renaissance Hotel in Richardson, Texas. City firefighters often have to deal with elevator emergencies. These may include fire and EMS emergencies, where crews manually take over the operation of elevators, or the rescue of trapped occupants on a malfunctioning elevator. Firefighters must understand how elevators work in order to function during an elevator emergency. They need to know how the elevator system is set up, what keys and tools they need, and how the controls on the elevator work when the elevators are in firefighter emergency mode. Although firefighters in medium to large metropolitan cities often have to deal with elevators in low and high-rise buildings, rural and small-town firefighters may rarely experience an elevator emergency. But the potential is still there, and when the situation arises, they must be educated and prepared to answer the call. Emergency personnel need to be proficient in elevator design and usage in order to be competent during these situations. In today's world, because of better economic feasibility and with so much progress in technology, we may see elevators in the multi-story homes of individuals with disabilities. The Americans with Disabilities Act states that all buildings over 2 stories must have elevators. Local building codes may even require elevators for the disabled in buildings over 1 story tall. With this in mind, even firefighters in rural areas may be called to this type of rescue or emergency situation. Elevator emergencies are no longer just an issue for major metropolitan cities. This course consists of the video, written materials, and a post-test. After studying this course, you should be able to describe different types of elevators that may be encountered in an emergency situation, including hydraulic and cable-operated elevators. Explain how to operate an elevator during an emergency situation and list tools that are used in elevator emergencies. Identify dangers of elevator rescue. Demonstrate how to perform various elevator rescues. Let's look at the different types of elevators that may be encountered in an emergency situation, including hydraulic and cable-operated elevators. Firefighters need to be familiar with the operations and components of elevator systems in order to be efficient and helpful during an emergency situation. Elevators generally operate on either electricity, alternating or direct current, or hydraulics. Components include the hoistway shaft with hoisting ropes, roller guides, traveling cable, elevator rail, and counterweight. Below the hoistway, you will find the car and counterweight buffers and the governor tension sheave. Firefighters will usually encounter only 2 main types of elevators in emergency situations. The most basic types of elevator systems encountered today are hydraulic and traction systems. Hydraulic systems are usually seen in residential elevators and in occupancies that are no more than 5 stories in height. However, they may be used in buildings of 6 to 8 stories. Hydraulic elevators use a plunger piston powered by hydraulics to push the elevator car upwards. A hydraulic system includes the doors, the hoistway, the car, a piston which is long enough to reach the highest floor and will extend the same distance into the ground, a fluid tank controller which is operated by an electric pump, car buffer, and in-ground cylinder. Hydraulic elevators do not have brakes. They are stopped by the controlled flow of hydraulic fluid. Buildings over 6 stories are more likely to use a traction-type elevator. The traction system operates electrically with the use of cables and counterbalance weights. A machine room is usually located at the top of the hoistway. In the traction system, there is the door, governor, control, drive and brake system. Geared or gearless traction systems are driven by electric motors. Geared machines roll steel hoist ropes over a drive sheave attached to a gearbox which is driven by a high-speed motor. A brake is mounted between the drive sheave and the end of the motor on a gearless traction system. If a power failure occurs, the brake will engage and prevent the elevator from falling. There are a few other types of elevator systems, including drum systems, which are usually found in old freight elevators. They're practically obsolete. The Otis Elevator Company has developed the new Gen 2 system, which is gearless and facilitates its use with coated steel belts. The Otis Gen 2 is a machine roomless elevator. The control panel is in the hoistway. Do all elevators have brakes? The answer is no. Hydraulic elevators do not have brakes. They are stopped by the control flow of hydraulic fluid. Now we want to explain how to operate an elevator during emergency situations and show you what elevators do when they are on Phase 1 and Phase 2 emergency operations. First, let's look at the keys and the tools that we need when we work with elevators in an emergency situation. There are a variety of tools that may be needed for elevator emergencies. Of course, the most obvious and the most used is the elevator emergency operation key. Other vital keys would be the hoistway door keys, including the T-shaped key, lunar key, and drop key. Commercial keys are now available, such as the new universal elevator key or the standard elevator key ring set, which holds 12 various keys on a jailer's ring. Some states, like Florida, are going to a uniform elevator key system, which combines the required keys in one tool, alleviating the necessity for a variety of keys. Firemen may also need to use an axe, a pry bar, or a Halligan tool. Ropes and rappelling equipment may be necessary depending on the situation. At times, firemen might need to use an A-frame or a roof ladder. Sometimes good old American ingenuity may be required to develop specialized elevator rescue tools. Constant communication is essential. Make sure that everyone involved in the elevator rescue situation has a radio or some other reliable means of communication. The plain fact is that if you have elevators in your response area, then you must have all the proper tools to get the job done. All personnel must know which tools to use and how to use them. These conditions only come from pre-emergency planning and preparation.
Our first priority will be if we have to breach an elevator door and enter in that direction to get the patient or victim out. Our first priority is going to be shut the power down, because we don't want that system to reset while we're moving a patient through the elevator. So we'll shut complete power down, and then we'll use these tools, and depending on which elevator, and that's just knowing your buildings and which doors you have, some of the different tools. Probably the most used is the drop key. We'll use those, open the door up, get to the patient, and if it's safe and they're within a good distance, we'll go ahead and remove the victims. Occasionally the elevator may be at an area where it's right between two floors, hard to get to, and at those times, if the patients are okay, we'll usually just keep talking with them, keep them there until we can get the actual engineers here to work on the system. If not, there are some of the systems that will know how to operate the hydraulics and lower the elevator down to a floor where we can safely remove the victim.
So one of the biggest keys is make sure the power's down, because that's one of the greatest dangers in a rescue situation. You want to try to use the keys, and if we can look right here at the top of the elevator, you'll find a hole, and that's the most likely place that you'll be using your keys. The last resort is if you have no other way, you might use a Halligan tool or pry bar to try and pry the doors apart, especially if you have an elevator that's stuck mid-floor. Now, in very specialized, unusual circumstances, you may actually have to rappel down a hoistway to a car, and then you want to be sure that the car is stable, there's no electrical hazards to firefighters, no car falling hazard. So those are in very extreme circumstances. So those are some of the tools that may be used on elevator rescues. Next, fire department personnel must be trained and prepared to handle emergency elevator operations. There are basically two types of elevator operations: Phase 1 and Phase 2 operations. Phase 1 fire service operation can be activated in two ways. A smoke detector located in an elevator lobby, machine room, or hoistway could automatically activate Phase 1, or manual operation of the three-position key switch located in the main lobby of the elevator. The three positions available on the switch are off, on, and bypass. Of course, one of the most important things you want to do when you come to an elevator emergency is try to find the building engineer, facilities management, Whoever has knowledge about the systems in the building, you may even want to contact security. The keys may be found in a Knox box if they have a Knox box, or those individuals will have a key. And Dustin, they know firefighters here. They've actually put up an operations guide right next to the elevators to give us reminders on how to operate them. Now, when we get the key, either from the engineer or the Knox box, we're going to come here and we find the phase operation for this system. What are we going to do, Dustin?
Well, first thing we want to do is if we need to recall all the elevators, we put the key in, turn it to the on position, which will recall all the elevators down to the designated floor. It may be the first floor, but there will be a designated floor. That will be something they need to find out beforehand.
Right, it depends on the type of building. You can have super high, tall structures that there's blind shafts, and elevators may return to different floors in the building. But in a building like this, we can see that all the elevators have returned to the first floor now. So what will we do in another operation?
This also has a bypass operation. I turn it to bypass. That will give the firefighters the ability to choose to bypass it within the individual cars and go to the floors they need to go to.
The car can bypass fire service with the use of the key. This overrides the signal from the smoke detectors and places the car back into normal service while the detector is repaired. The key is non-removable in this position. Here is the procedure while the elevator cars are in Phase 1 operation. All cars traveling away from the recall floor will stop at or before the next available landing and reverse direction without opening their doors. All cars standing at a floor will immediately close their doors and return to the recall floor. Once doors close and the car moves away from the landing, the emergency stop switch and in-car stop switch become inoperative. Smoke or flame-sensitive door reopening devices also become inoperative. Door reopening devices which are not sensitive to smoke or flame are permitted to remain operative. An audible and illuminated signal comes on and remains on until the car returns to the lobby. Once the car moves, the in-car door open button becomes inoperative. There can also be an auxiliary 2-position switch in a remote location such as a fire control room or guard station. This switch cannot override the 3-position switch. It can only have on and off functions. The switch can recall elevators to the lobby and can turn on Phase 1 operation. If this switch is in the on position, the bypass and off position on the 3-position switches will not work. To remove the car from Phase 1 operation, personnel must return the car to the designated landing, then with the doors open, turn the lobby 3-position switch to off position. Phase 2 was created so firefighters could rescue victims from a burning building. It can only be activated by placing the fire service key into the fire service Phase 2 switch inside the elevator on the centralized control panel in or adjacent to the car opening panel. The Phase 2 switch has 3 positions. Off, normal operations. On, places the car under direct control of firefighters in the car. Or hold, which allows the user to control the use of the elevator. The operation of the car must follow a sequence of operations. A change in the key position is only recognized by the elevator system when the elevator is stopped at a floor and the doors are fully opened. The sequence is: turn the lobby switch to on to activate Phase 1 operation, turn the in-car switch to on, press and hold the door closed button until the doors are fully closed. If the door close button is released before the doors are fully closed, the doors will reopen automatically. Press the button for the desired floor. Upon arrival at the desired floor, press and hold the door open button until the doors are fully open. To hold the car at the floor, turn to the hold position when the doors are open and remove the key. With the doors open, turn the key to the off position to return the car to the recall floor in order to allow others to use it. To remove the car from Phase 2 operation, return the car to the recall floor, then with the doors open, place the key switch in the off position. The most important factor is that firefighters must know who has the elevator key or where the key is located. What is the tool that firefighters must locate before they can proceed with an elevator emergency operation? The most important tool is that firefighters must know who has the elevator key or where that key is located. There are many dangers associated with elevators that need to be recognized by firefighters. High voltage, unfamiliarization with elevator systems, mechanical operations, heights. A combination of these and/or other hazards must be recognized in dealing with elevators. Electricity is considered to be one of the most significant hazards associated with elevator rescue. Elevators can use tremendous power supplies. They utilize either alternating AC or direct current DC. Sometimes as much as 500 volts of power will be present for elevator operation. High voltage is one of the most predominant safety hazards rescuers must account for. Therefore, firefighters must watch out for electricity and should learn how and when to shut it down. This type of emergency may not be commonplace in mid-sized to small or even rural communities. Therefore, unfamiliarization of elevator systems can be a great detriment to firefighters. That's why we're offering this training course. The mechanical operations of elevators are unique and can pose problems for firefighting personnel. Prior knowledge of how an elevator operates and what to expect an elevator to do is of great value to a professional when he or she is called upon to rescue civilians from an elevator or to deal with elevators in a fire situation. Moderate to extreme heights and the openness of hoistways present dangers and challenges to firefighters and also to persons who need to be rescued from an elevator. Here are some safety tips for elevator emergencies. Whenever possible, seek professional assistance from building maintenance engineers or an elevator mechanic. In fact, knowing who to contact and how to contact them is very important. Building maintenance personnel or the local elevator service company may be your best friend in this situation. Always wear standard protective PPE, personal protective equipment. If necessary, shut down power to the car or cars involved. Be sure the emergency stop switch button inside a malfunctioning car is activated. Never leave open hoistway doors unattended. Use lifelines for rescue operations as appropriate. Never try to repair a malfunctioning elevator system. Leave this to elevator professionals. For more information, consult the IFSTA Fire Service Rescue Manual from ifsta.org. True or false? Sometimes as much as 500 volts of power will be present for elevator operation. The answer is true. We must stress that electricity is one of your greatest hazards, and sometimes as much as 500 volts of power will be present for elevator operation. Now we'd like to discuss how to perform various elevator rescues. There are many scenarios in which an elevator emergency may occur. Remember, if there are individuals trapped in an elevator that are not in danger, the best method for rescue may be just to protect in place and seek the help of building maintenance personnel or a local elevator company specialist. Here are some sequences to follow during elevator emergencies. Before conducting an evacuation, take these steps. Communicate with the occupants of the elevator car to inform them that they are safe. Steps are being taken to evacuate them from the car. They should stand clear of the doors since they may be opened. Find out the answers to the following questions. They'll be your guide in your rescue decisions. How many people are in the car? Are any of the occupants ill or injured? Are the lights in the car on? Where is the car in the hoistway? While the operation is in progress, the occupants of the car should continually be kept informed of actions that affect them, and they should be constantly reassured of their safety. The preferred safe practice in evacuating passengers is to move the elevator car to a landing level. The procedures outlined herein do not require the movement of the elevator car by any other means other than inspection or Phase 1 operation. Movement of the car by any other means should be only attempted under the direct supervision of experienced elevator personnel. Before utilizing any of these procedures to move the car, make certain that the main electrical disconnect switch is in the on position and that the emergency stop switch, if equipped, is in the run position, not in the stop position. Stop disconnects the mainline electrical connection from the motor. If the elevator is equipped with firefighter service operation, try activating the Phase 1 lobby key switch to recall the elevator cars to the main floor. If the car is stalled due to the loss of power in the building, and the building has a standby or emergency power source equipped to operate the elevators, it may be possible to run the elevators by turning the emergency recall switch in the main floor lobby to the on position. If these methods do not work, determine the position of the car and continue with whatever evacuation procedure is appropriate. When a car is located at or near a landing, it might be possible that the hoistway door is unlocked and the hoistway and car doors can be opened by hand. Under these conditions, proceed as follows. Turn off the main electrical disconnect switch. Open the doors by hand. Enter the elevator car and set the emergency stop switch, if equipped, in the stop position. Assist the passengers in leaving the car one at a time. If the car is not level with the landing, make sure that the passengers do not trip or fall while leaving the car. In some instances, this may necessitate the use of a small ladder like an A-frame or roof ladder to help extricate passengers from the car. When the hoistway doors are not unlocked and the car floor is within 3 feet of the landing level, the following methods of removing the passengers should be used. Method 1. Open the doors from the landing. Turn off the main electrical disconnect switch. Unlock the hoistway door at the floor nearest to the stalled car by using the elevator door interlock release key, and open the hoistway and car doors by hand. Newer car doors have interlocks to keep the car doors from being opened from the inside of the car. Locate and override. Enter the car and place the emergency stop switch, if equipped, in the stop position. Assist passengers in leaving the car one at a time. Precautions should be taken to guard any hoistway opening below the car floor when the car is above the landing. Method 2. Opening the doors with a forcible entry tool. Where the hoistway doors cannot be unlocked by an unlocking device or by other means, the hoistway door at the floor nearest the stalled car can be forced open as follows. Turn off the main electrical disconnect switch. Open the doors with the use of a forcible entry tool. It should be used at the top of the doors where the interlock is located to minimize damage to the doors and to allow for quicker return to normal service. Enter the car and place the emergency stop switch, if equipped, in the stop position. Assist the passengers in leaving the car one at a time. Precautions should be taken to guard any hoistway opening below the car floor when the car is above the landing. When an elevator car is stalled so that the car floor is more than 3 feet above the landing level, it is inadvisable to remove the passengers through the elevator door opening. The excessive distance between the car floor and landing level creates a danger due to the possibility that a passenger may fall into the hoistway. Also, it's inadvisable to remove passengers through the elevator door opening when the car floor is more than 3 feet below the landing level, since the reduced opening clearance makes exiting too difficult. The recommended method for removing these passengers under these conditions is follows. Remove through the top emergency exit. Caution, do not use the top emergency exit on an elevator in an unclosed hoistway. New elevators in unclosed hoistways will not have top emergency exits. Turn off all main electrical disconnect switches servicing the cars in the same hoistway. Open the hoistway door at the nearest landing above the stalled elevator car top. Lower a ladder to the elevator car top and secure it in place. Ladder tips should extend 3 feet above the landing floor. One firefighter wearing a safety belt and tied off to a secured lifeline should descend to the top of the stalled car. Lower a second ladder through the top emergency exit. A second firefighter, also wearing safety belt and tied off to a secure lifeline, should then descend to the car top. Carry additional safety belts for use by the exiting passengers. One firefighter will enter the car and one will stay on top of the car, and a third should be positioned at the landing. Set the emergency stop switch, if equipped, in the stop position. Assist the passengers one at a time from within the car to the car top, then to the landing above with the use of safety belts and secured lifelines. Do not attempt to restore power to the stalled elevator. After removing the passengers, have a responsible party stand by to inform the elevator personnel which switches were pulled and which doors were forced open. If there are individuals trapped in an elevator that are not in danger, the best method for rescue may be to A. Protect in place, B. Use ropes and rappelling equipment to take the passengers down to safety, C. Use an axe or pry bar to open the door, then have them climb to safety, D. Override the braking mechanism and try to lower the car to the ground floor. The answer is A. If there are individuals trapped in an elevator that are not in danger, the best method for rescue may be just to protect in place and seek the help of building maintenance personnel or a local elevator company specialist. We presented the most common methods in elevator rescue situations. However, they're not exclusive. The most important factor is pre-fire and pre-emergency training and planning. You should study and know the types of elevators that are in your city and your response area. Here's a recap of what we've covered in this course. The types of operating systems. Traction, most used in buildings over 6 stories in height. Hydraulic, used in residential structures and buildings under 6 stories in height. Drum. These are old systems not in use much anymore, but may be found in old freight elevators. There are basically 2 types of firefighter elevator operation, Phase 1 and Phase 2 operation. Know the hazards. The main issues involved are electricity, mechanical, and heights. There are a variety of tools for elevator rescue. Be sure you have the right tools for any situation you might encounter. Make sure you know who has the elevator key or where the key is located. Finally, become best friends with the mechanical staff in buildings that have elevators and develop useful contacts with local elevator service companies. We'd like to thank the Bass Pro Shop in Garland, Texas and the Renaissance Hotel here in Richardson, Texas for their assistance with this program. For FETN, I'm Jeff Tokar saying until next time, be safe.